Hello and welcome to helpyourmath.com. In this video, we're going to look at examples of adding and subtracting rational expressions with unlike denominators. First, let's review my suggested steps for adding or subtracting rational expressions. First, we want to keep the numerators unfactored. Second, we want to factor each denominator. Third, we want to multiply any missing factors from each denominator as an equivalent of 1. So we want to factor the denominators, and then what should really say in there is find the LCD. So determine the LCD based on the factors that we have. And then we'll multiply any missing factors from each denominator as an equivalent of 1. Distribute in the numerator, but keep the denominators in factored form. Add or subtract the numerators. Keep in mind that if it is subtraction, the entire second numerator is being subtracted, and hence all the signs change. Combine the like terms in the numerator. See if the numerator can be factored, and then simplify if possible, meaning look for common factors between the numerator and denominator. Okay, so in our first example, we're adding, and we have two rational expressions. This denominator can't be factored, so that's it. That's the only factor of the denominator. This denominator can't be factored. So first, we're going to identify the least common denominator is going to be m minus 4 times m plus 5, just the product of the two factors. Now we're going to take whatever's missing from this denominator, which would be an m plus 5, and multiply it to both the denominator and the numerator, because if we do that, that's an equivalent of 1, so it's not really changing the value of the fraction. Over here, we're missing a factor of m minus 4, so we're going to multiply that to the numerator and the denominator. Now we're going to distribute in the numerators, but we're going to leave that denominator. And now that we have the same denominator, we can just write one giant fraction with that common denominator. So we're going to say m plus 5 times m minus 4. In the order in which you write those, it does not matter. Okay, so then m plus 5 times m would be m squared plus 5m. Then we have that plus sign, so that's good, plus, and that would give us 2m minus 8. Now we're going to clean up the numerator, so we have like terms right here. This would be m squared plus 7m minus 8 over m plus 5 times m minus 4. Lastly, we want to see if the numerator can be factored, and it can be. It could be m plus 8 times m minus 1 over m plus 5 times m minus 4. But then we see that the two factors of the numerator, they don't have any common factors with the denominator, so this would be our final sum. Our next example is subtraction, so we do want to be very, very careful with the subtraction. So step 1, we're going to leave the numerators alone. Even though I see that 2x plus 8, and we can definitely factor that, we don't want to. We want to leave it as 2x plus 8. The denominators, however, we do want to factor. X squared plus 4x plus 3, that's going to factor into x plus 3 times x plus 1. X squared plus 5x plus 6, that's going to factor into x plus 3 times x plus 2. Next, let's identify our least common denominator. So the least common denominator needs to include a factor of x plus 3, which actually appears in both denominators, so that's good. We also need a factor of x plus 1, and we also need a factor of x plus 2. So we need these three factors because these are the factors that make up any denominators. And if this is our least common denominator, here, this first fraction is missing the factor of x plus 2. So we're going to multiply both the denominator by x plus 2 and the numerator by x plus 2. And when we do that, we're going to take the given numerator and put it inside parentheses because we need to use the distributive property. The second fraction, x plus 3 times x plus 2, we're missing the factor of x plus 1. So we're going to multiply by x plus 1 under x plus 1. And again, we want to put that numerator in parentheses. We also want to be really careful with the subtraction. It's very easy to make mistakes with subtraction. So until we've dealt with this subtraction sign, we want to keep parentheses on this. Whatever we do here, we need to keep it inside parentheses until we deal with the subtraction that's directly in front of it. Okay, so now we can bring everything all together. We have our denominator of x plus 2 times x plus 3 times x plus 1. And our numerators, so we want to distribute the x plus 2 to 2x plus 8. That would be 2x squared plus 8x plus 4x plus 16 minus, and again, I'm going to keep the second everything inside parentheses, the expression, until I've dealt with this subtraction, because this subtraction is the all-powerful subtraction that was in between the two fractions initially. So this one needs to stay inside parentheses. It's going to be x squared plus 1x plus 4x plus 4. Now I do want to distribute that subtraction sign, so what that's going to do is going to change all the signs. I'm just going to do that here so I don't have to rewrite this all again. So negative, 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 and negative, and now I can change that to a plus. Now that that is a plus sign, I don't have to worry about it, but we have to be very careful that we distribute that subtraction sign. Okay, now we can look for like terms. We have 2x squared and negative x squared, so that would be x squared. I'm just going to cross those out so I don't look for them again. We have 8x plus 4x is 12x, minus x is 11x, minus 4x is plus 7x. Okay, these are done. And then our constants, we have 16 and negative 4, that would be plus 12. So all this is going over x plus 2 times x plus 3 times x plus 1. And lastly, we want to see, can we factor the numerator, x squared plus 7x plus 12? Target product is 12. Target sum is 7. There is a winning combination, 3 and 4 works. So we're going to punch those in. That would be x plus 3 times x plus 4 all over x plus 2 times x plus 3 times x plus 1. And we want to see, do we have any common factors between the numerator and the denominator? We do. We have an x plus 3 factor, so we can cancel those, leaving us with x plus 4 in the numerator and x plus 2 times x plus 1 in the denominator. You always have to check with your instructor if you can leave the denominator in factored form. Personally, I'm fine with it. I think less is more in this case. Just leave it like that and call it a day. Okay, our next example, we have 2. So 2 is not quite in rational expression form. If we're going to turn 2 into a fraction, we would put it over 1. The second one is, it's fine. So now the least common denominator, we don't have to worry about the 1. So this is the least common denominator, 3x plus 1. Now, in order for 1 to turn into 3x plus 1, we need to multiply it by 3x plus 1. Sometimes students think that we can just like add a 3x, but when we're writing equivalent fractions, you can't use addition. You have to use multiplication. So we have to multiply by that entire factor, 3x plus 1. All right, now we have our common denominator, 3x plus 1. We're going to distribute in the numerator. 3x times 2 is 6x, and 1 times 2 is 2. And then what are we doing? Subtracting 9. So then this would become 6x minus 7 over 3x plus 1. 6x minus 7 cannot be factored. 3x plus 1 can't be factored. This would be our final difference. In our last example, we want to factor the denominators. So this would be 2 times x plus 5. And this is a difference of squares. It's going to be root minus root times root plus root. Now we can identify our least common denominator. It needs to include a factor of 2. We need a factor of x plus 5. And we also need a factor of x minus 5. Now we're missing the factor of x minus 5 from our first rational expression. So we're going to multiply both the numerator and denominator by x minus 5. And we're missing a factor of 2 in our second fraction. So we're going to multiply by 2. And while we do need to be careful because we do have this subtraction here, there is only one term behind it, so we're pretty safe there. All right, so I'm going to write my common denominator, 2 times x plus 5 times x minus 5. And then I'm going to distribute the x minus 5 to x plus 4. That would be x squared plus 4x minus 5x minus 20. Then minus 5 times 2 is 10. Cleaning this up, we're going to have x squared minus x minus 30 over 2 times x plus 5 times x minus 5. And we want to see, can we factor the numerator? Target product is negative 30, target sum is negative 1. Yeah, we have a winning combination. We have positive 5 and negative 6. So we could write this as x plus 5 times x minus 6. And then we have our denominator, x plus 5 times x minus 5 times 2. These we can cancel out, leaving us with x minus 6 over 2 times x minus 5. And I would just leave it like this and call it a day.